Okay, so what is a solid of rotation? Basically, it's going to be an area that we've enclosed between two or more functions, which then we take and we rotate it around an axis to form a three-dimensional shape of sorts. It could be a cylinder, it could be some sort of, not a quite pyramid, but a cone. It could be various things, really. So first, let's go into area. So area is going to be a two-dimensional space that is in a given area, basically. So in this case, we're going to look at how to find area of this. So on the bottom here, that lower line, this is the x-axis. And we have the y here as well. And we have a function which looks something like a parabola right there. And what we want to do is find the area between the x-axis and this parabola. So that's going to be all in here. The points at which the parabola and the x-axis intersect we'll call A and B. A starts all the way on the left. It would actually be a negative in this case, and B would be on the right, a positive. So along this point, we're going to look for the area enclosed. So our formula is going to look like the integral from A to B of f of x dx. So f of x, we're looking at the y value at each point along the values from A to B between those two functions, the x-axis and the parabola f of x. Now, when we're actually doing solids of rotation, what we're doing is we're taking the area and spinning it around. So in that process, really, if you think about if you just pick one specific x-coordinate, you're going to form a circle. If you were to slice it transversely and take a look, it would just look like a circle. So what we can do is we can actually use this idea to calculate the volume. So the volume of a cylinder is pi r squared h. And in the case of solids of rotation, we're talking about a ton of really infinitely small cylinders that we are going to find the area of and add together, really. So pi is going to be equal to pi. Then we're going to multiply this by the integral. We have a to b, and then r squared. We're going to go ahead and say f of x, and we're going to square it. So that's our radius right there, f of x. And then multiply this by h, and what is h in this case? It's dx. It's the change in x. Perfect. And what this is going to do is go ahead and give us a bunch of really thin cylinders, which are basically circles, which we can then use to add together and calculate the area of the total shape. So let's take a look at this, for example. This will be example number 1. So we're going to use three functions in this case. The x-axis, the y-axis, and a linear function, which is 1 minus x right here. So we need some information here. We need to find a and b. So just looking at this immediately, you can see that the leftmost portion where it's going to be intersection with, which will be a, is going to be 0 right there. And on the right side, where we're going to be intersecting, is going to be 1. Because if we go ahead and do 1 minus x, we know that that's going to get us out 0, and that means it's going to be crossing the x-axis, at which point it's no longer going to be bound between the x and the y, which we don't care about the area anymore at that point. So now we're going to make an integral for it. So first off, remember our formula, pi r squared h. So pi multiplied by r. So r is going to be a to b. Remember, we had an a left side of 0, and on the right it intersected at 1, so that's b. So r squared, that's going to be 1 minus x squared, and then dx, so h. So the derivative of x, we're talking about the infinitely small change as we're going from one point to another. So that's exactly it right there. And if we go ahead and calculate this out, we are actually going to get 1.571. Let's go ahead and try one that's a little bit more difficult now. So we're not going to actually use the x or the y-axis for this one. So we're going to say we'll rotate around the line y equals 2. So we'll call that right down. 2, y equals 2. Great. And then we're going to have two functions that we're using here to enclose an area. So for the lower function, we will use y equals 5. And for the upper function, we'll go ahead and use 10 minus x squared. And of course, this isn't exact, but it's a really good representation because I'm an excellent drawer. So we're going to have 10 minus x squared and y equals 5. So we're going to need to calculate a couple things. Point of intersections. So that's going to be plus or minus 2.236. So at these 2 points, the x values are going to be equal to positive and negative 2.236. So that's going to give us our a and our b. So with that, then we can go ahead and make our integral. Now, on the top, if we go back for just a second, we can see that this function is lying on top. So we're just going to remember that and come back to that in a moment. And this one, y equals 5, is on the bottom. So when we make our integral, we're going to go first off, pi times the integral from negative 2.236 to positive 2.236. And this is going to be of the two functions we're going to do. On the top, we're going to put the upper function, because what we're doing here is we're making a radius, which we are using to calculate our area. So if our radius is going from bottom to top, then that means that we're going to get a negative value, which is going to give us a negative area, which we don't really want because that's not real then. So we're going to do 10 minus x squared, and oh wait, remember now, we had y equals 2 as our point of rotation. So we're going to do minus 2. We're going to square this. And then we're going to subtract from that bottom function, y equals 5. Oh, remember, minus 2. We're going to square that, and it's kind of down here now, and we dx. So that's our h. So we have it all written out. Now we're going to go ahead and calculate that, and it's just going to get us 468.321. So important things we need to remember. First off, our formula, pi times the integral from a to b of f of x squared dx. And the f of x squared, it won't always manifest itself as just one simple thing. Sometimes it'll be two functions with the upper minus the lower, and you're going to square them separately, not together. Right about there. And then as far as rotation axis, so if we're not rotating on the x or the y axis, we want to be really careful to go ahead and either subtract or add, so it's going to be negative x, negative y, as we are going ahead and putting it in, because we don't want to think of it as rotating around the x or the y axis. It's not supposed to be, because that will just ruin our final answer. And that is going to about sum up solves for rotation.